Alright, well, welcome back to Scholar's Drive doing some math. Today we'll be analyzing arithmetic sequences in series. So, last time we were looking generally at sequences in series, like we're trying to look at these patterns here, and, we're not, can't, there's no, there was no structure. We kind of like, oh, this pattern is this pattern is this. Now we're going to start breaking them down into some hopefully easier to work with, and then we'll have a better understanding of this. Let's start off with the arithmetic sequence. Arithmetic sequence is there's usually a difference between consecutive terms as constant, and the next term is found by adding that constant. So, for example, we have 1, 3, 5, 7. That means our common difference here is plus 2. Right, we're adding plus 2, plus 2, plus 2. If we wanted to find the next term, we would just add 2, which is 9. And then D is known as the common difference. So, in this case, D would equal 2. Because we're adding 2 to each thing. So, it's arithmetic if the difference between each term is the same. So, tell whether the sequence is arithmetic or not. If so, determine the common difference. So, this one is minus 5, minus 6, and I could stop right there, but we can keep going. Minus 4, minus 7, not arithmetic, non-arithmetic. Here we have, going down from 20 to 12, we get minus 8. 12 to 4, that's minus 8. 4 to negative 4, that's minus 8. So that is arithmetic. And that is a common difference of minus 8. Okay. Rules for an arithmetic sequence. So if it's an arithmetic sequence, we can find the nth term. As long as we know the first term, A1, and a common difference, D. So if I wanted to find, so let's use B as an example. So here's B, my equation. If I wanted to find a sub 5, which means the fifth term, I would start off with my first term, which is 20, plus n minus 1. So n is 5. I'm looking for the fifth term, minus 1 times D, which would be 20 plus 4D. So D is my common difference, which was negative 8 up there. So 20 minus 32, and that should give me negative 12. So negative 12 would be the fifth term here in my sequence. Hopefully that's not too bad. Let's do another example, hopefully. I say hopefully because I'm not in control of these notes here. There we go. Good. So write a rule for the nth term of the sequence with the given information. Then find a sub 20. So this is something you should memorize, this formula here. This is for arithmetic. So a sub n, or continuously keep writing on your paper every time there's a quiz or a test. A sub n equals a sub 1 plus n minus 1 times d. Okay. So write a rule for the nth term. So the rule is a sub n equals 2. That's the first term. Plus n minus 1 times d. So d is, and you got to make sure that the difference is the same, which it is. So plus 7. Okay. So my formula is going to look like this. 2 plus distribute 7n minus 7. So a sub n equals 7n minus 5. So this is my rule. Okay. And now they want to find a sub 20. So the 20th term is equal to 7 times 20 minus 5, which is 140, minus 5, which is 135. So that's my 20th term. Part B. So let's find out our common difference. Plus 6, plus 6, plus 6. Good. That means this is arithmetic. So that means we can use this formula. A sub n equals the first term, which is negative 15, plus n minus 1 times 6, which is my common difference. Distribute. Got a sub n equals negative 15 plus 6n minus 6. So that'll be 6n minus 21. Find a sub 20. Six times 20 minus 21. 120 minus 21 is 99. Part C. So they tell you that ace of 11 is 41 and d equals 5. So we need to find the rule. So ace of 11 is equal to ace of 1 plus 11 minus 1 times 5. So I'm working backwards to find out what a of 1 is, and then I can figure out my rule. So we know that a of 11 is 41 equals a1 plus 55, 11 minus 1 is 10, times 5 is 50. So I'm going to subtract 50 from both sides, and I'll get negative 9 equals a1. So my rule, a sub n equals negative 9, n minus 1 times 5. Distribute. So I'll have negative 9 plus 5n minus 5. So a sub n equals 5n minus 14. So here is my rule. And then they just want us to graph. So I create this here. And so we're going to start at our y-intercept. So my equation is y equals 5n minus 14. So I start off at negative 14. I'm going to go up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. And hopefully you get a straight line. If you need a table, if you want to make this a lot more accurate. So here's n, here's a sub n. If I plug 1 in, I'll get negative 9. Plug 2 in, get negative 4. Plug 3 in, get 1. Plug 4 in, get 6. And obviously if you plug in 0, you get negative 14. Okay. More vocabulary. Arithmetic mean. So the arithmetic mean is the term between any two terms of an arithmetic sequence. Arithmetic sequence. Which is basically means you add the two terms together and then divide by 2. So find the missing terms of the arithmetic sequence. So if we wanted to find this middle term here, we would take 7 plus 23 and then divide by 2. So we get 30 divided by 2, which is 15. 15's in the middle. So to get in between 7 and 15, we do the same thing. 7 plus 15 divided by 2 equals 22 divided by 2, which is 11. This only works with arithmetic sequences, because now we can notice that the common difference here is we're adding 4. 4, add 4 again, that's 19, and add 4. Okay, try it. Part 4, find the number of terms in the arithmetic sequence. So we know that this is 3 here. That's 3. We're adding 3. So our common difference here is 3. And we could count it out, like this is the third term, the fourth term would be 16, and then we would keep going until we make it to 55. But there's a faster way of doing this. So first we write out our equation. So a sub n equals a sub 1 times, or not times, plus n minus 1 times d. And our first term is 7. So when I plug it in, a sub n equals 7 plus n minus 1 times d, which is 3. So a sub n equals 7 plus 3n minus 3. So my formula, my rule, is 3n 7 minus 3, which is plus 4. Okay. Now that I have my rule, I can just set my last term. So my last term is 55, right? And we're trying to find out what that is. So 55 equals 3n plus 4. So we subtract 4, we'll get 51 equals 3n. So n equals 17. So that is the 17th term. 55 is the 17th term. Alright, let's move on. Part 5. Write a rule for the nth term of the arithmetic sequence given 2 terms. So we have a6 equals 7 and a20. We have the 6th term equals 7, and we have the 22nd term is 87. So remember, we're trying to write this rule. A sub n equals a sub 1 times, sorry, I keep saying times, but it's plus n minus 1 d. So I need to find d. I need to find the first term as well. How do we do that? Plug a sub 6 in. So a sub 6 is equal to a1, which we don't know, plus n minus 1 times d. which we know n is 6. And we know that a sub 6 is 7. So 7 equals a1 plus 5d. And then a sub 22. So here's my first formula here. And then my second one. So a sub 22 equals a1 plus 22 minus 1 times d. So 87 equals a1 plus 21d. Now I have two different equations with two unknowns. That means we have a system of equations. So I'm going to go ahead and put them on top of each other. So I'm going to remove this box here. So once again, this was 7 equals a1 plus 5d. And then 87 equals, here's my second equation, a1 plus 21d. So what I'm just going to do is subtract the equations. So I'm going to take equation 1 and subtract equation 2. So 7 minus 87 is negative 80. A1 minus A1 goes away, and I have 5d minus 21d, which is negative 16d. Divide by negative 16, and it'll get d equals 5. And now that I know what d equals, I can plug it back into one of these equations, and I will get where is it? So I plug d back into any of these equations here. I'll do the first one. So 7 equals a1 plus 5d, which is 5 times 5, which is 25. So a1 is equal to negative 18. So my rule, finally, is a sub n equals negative 18 plus n minus 1 times d, which is 5. So a sub n equals negative 18 plus 5n minus 5. So a sub n equals 5n minus 23. Sorry for going all over the place. That was a lot of work. Part B, you would do the same thing. I'm not going to do the whole thing, but I'll set it up. So a sub 15 equals a1 plus 91, or not 91, 15 minus 1 times d, and then you plug 91 in, a1 plus 14d. That would be my first equation. My second equation would be 1 equals a1 plus 20 minus 1d. So 1 equals a1 plus 19d. So those are my two equations. And then I would subtract, find d, find a sub 1, and then rewrite my equation. Like I said, I'm not going to do it all. So number 4, arithmetic series. So an arithmetic series, so a sequence is, just a series of sequences of numbers. And then a series means we're adding all of them. So we usually use the term S of n. So adding terms in an arithmetic sequence. The sum of a finite arithmetic series is S of n, which is the average of the first n terms first nth terms of a sequence multiplied by how many terms there are. So you add the first term and the last term, you find the average by dividing by 2, and then you multiply by how many there are. And that's how you find the sum of the finite. So you need to know the last term, you need to know the first term, and you need to know how many terms there are. So for example, so we have this here. So we need to find A1 and a sub n, which is 18 in this case. So a sub 1 equals 77 minus 4i, which 4 times 1. So 77 minus 4 is 73. And then 77 minus 4 times 18, which means 77 minus 72. So that should be 5. And then we plug it into our equation here. S of n equals n, which is 18. Number of terms. A1 is my first term, 73, plus 5, my last term, divided by 2. So I'll get 18 times 78 divided by 2, which is 18 times 39, which is equal to 702. So what does this number mean? Is if we plugged in all the terms, plug 1 in the equation, 2 in the equation, 3 in the equation, all the way up to 18 in the equation, and we add them together, we'll get 702. Let's use a word problem. A theater has 60 seats in the first row, 68 seats in the second row, 76 seats in the third row, and so on in the same increasing pattern. If the theater has 20 rows, how many seats are there in the theater? So we have 60 in the first row, 68 in the second, 76. So obviously this is arithmetic because we're in the arithmetic section. So that means they should have a common difference. In this case, D equals 8. We know that A1 is 60. Okay. So if I wanted to write the rule would be A sub n equals 60 plus n minus 1 times my common difference 8. So that would be 60 plus 8n minus 8. So this is 8n plus 52. So that's my equation. Now, why do I have this equation? Because I need to find the last term. And just a little bit of practice. If I wanted to write this in sigma notation, I have this going on. We have 20 rows. I equals 1. And I'll just change my n into an I. And that's how you would write that in sigma notation. Okay. But we don't need that. We just want this formula here. A1 plus an divided by 2. We're trying to find the sum of all the seats, how many seats there are in the theater. So I need to find a of 20. So I plug a of 20 in the equation. I'll get 8 times 20 plus 52, which is 160 plus 52, 212. So I finally plug it in this formula here. So n, which is 20 rows, a of 1, the first term was 60, plus my last, there's 212 seats in the last row, divided by 2. So I'll get 20, 272 divided by 2, which is 20 times 136, which will be 2,720 seats total. Oops. And now we can sell tickets, knowing how many tickets we can print out, because that's how many seats there are. Blah, blah, blah. Do some pricing. Calculate how much we should charge for each ticket based on how much did it take to get this, whatever we're performing or whatever's going on, how much do they cost, so on and so forth. Lots more math involved in business when it comes to theater. But that's just one type of example we use sequences and series for. Hopefully this helps you out. Have a good day. Hopefully this is a lot easier. The big thing is this formula. Let me just rewrite it. A of n equals a1 plus n minus 1 times d, where d is the common difference, n is whatever term you're looking for, and a of 1 is the first term. And you can rewrite any of these arithmetic sequences into this type of formula. And if you want to find the sum of all those terms, then use this formula. Alright, have a good day.